Hello everyone. Today we will study the topic from electrical measurement and measuring instrument, and that is what we are going to discuss here. That is introduction, essential system of indicating instrument, PMC instrument, and conclusion. So what is electrical measuring instruments? The instruments used for measurement of electrical quantity is called measuring instrument. So in electrical measuring instrument we have different types of instrument. So in this topic we will discuss about the indicating instrument. What is indicating instrument? So the indicating instrument indicate the value of the electrical quantity to be measured generally by the deflection of the pointer. So what are the different types of indicating instrument? The instruments are ammeter, voltmeter and wattmeter. So generally indicating instruments are subjected to different torques. What are the different torques are there? First one is deflating torque, next one is controlling torque, and third one is the damping torque. So any indicating instrument are subjected to three torques, that is the deflating torque, controlling torque and damping torque. What is the deflating torque? So these torques move the pointer from initial position to the final position. So this deflating torque can be produced by utilizing different effects. We have electromagnetic effect, magnetic effect, hot air effect, electrostatic effect, chemical effect. By utilizing these effects, we can move the pointer from initial position to the final position. Next, we have control torque. So it is also called restoring torque. We have to restore the torque, or we have to restore or control the pointer movement. So this is the called controlling torque. So without control torque, the pointer moves indefinitely. So there are different methods for providing the control torque. First one is spring control, another one is gravity control. So what is spring control? In this spring control method, we can use two phosphor bond spring, one at top, another at bottom. This are wound in clockwise direction, another wound is anti-clockwise direction. Due to the effect of deflating torque, when pointer moves from initial position to final position, one spring get twisted in clockwise direction, another twisted in anti-clockwise direction. So this twisting force opposes the movement of the pointer. And the steady position when deflating torque is equal to control torque. So see here, deflating torque is directly proportional to current and control torque is directly proportional to angle of deflection. And at final position, deflating torque is equal to the control torque, and here we can, in spring control instrument, we can provide the linear scale. Next one is gravity control. So in gravity control instrument, small weight is attached, that is the called control weight. So due to action of gravity, so pointer comes to the initial position from the final position. So we can provide here balance weight, another weight for balance the pointer, that is called balance weight. But demerits of this gravity control instrument, we have to keep the instrument in vertical position, and here scale is non-linear. Third torque we can provide, that is the damping torque. Damping torque removes the oscillation of the pointer at final position. So depending on the force required, we can classify into three types, that is the critically damped, under damped and over damped. So damping torque produced by following methods, that the air friction damping, eddy current damping and fluid friction damping. So in degree of damping, see here, so we have damping force what required for an instrument is critically damped, and if the damping force is more than required, that is called over damped situation, and if the damping force is less than what required, that is the called under damped situation. See the figure here, the graph between the time and final deflection. Here in critical damped situation, see here, pointer comes to the final position slowly and moves to the final position in proper time. If it is over damped situation, so it takes more time, that instrument become very slow and sluggish. If the damping force is less than what is required, that is called under damped system. The at least it is strictly avoided if the under damped situation is there in any instrument. See here, we have three types of damping, that is the eddy current damping and fluid friction damping and air friction damping. See here, that the figure shows the eddy current damping. So eddy current damping, we have permanent magnet here. Inside the permanent magnet we have one aluminum disc. When pointer deflects from initial position to final position, the aluminum disc starts vibrating inside the damping magnet, that produces the eddy current. So that eddy current opposes the movement of the pointer, so that produces the damping. Next types of damping is fluid friction damping. So generally a light disc is put inside the oil. So when instrument deflects, this disc vibrate inside the oil. So viscosity of the oil opposes the movement of the pointer, so that provides the fluid friction damping. But demerits of this type of damping is it is rarely used, because we have to keep the instrument in vertical position. Next, most effective method of damping is air friction damping. So in this method we have one air chamber. There is a piston attached inside the air chamber. When there is a movement of the pointer, so this piston moves inside the air chamber. So due to compression and expansion of the air inside the air chamber, vibration of the pointer stops. So these are the essentials of the indicating instrument. One of the most important instrument is indicating instrument is the PMMC instrument. See here, we have moving coil instrument, that is the PMMC instrument, and dynamometer type instrument. Generally PMMC instrument are used for only DC measurement. DC ammeter and DC voltmeter are PMMC instrument. Another instrument is dynamometer type. Generally wattmeter is dynamometer type instrument. What is the basic principle of PMMC instrument? So whenever the current carrying conductor placed inside a magnetic field, that pointer experiences one force. That direction of the force is defined by Fleming's left hand rule. What is the construction of the PMC instrument? PMC instrument of permanent magnet. Generally alnico material is used for making a permanent magnet. Rectangular moving coil. Aluminum cylindrical core. That coil is placed over the cylindrical core. Control spring, generally two phosphor bone spiral springs are there, and pointer and scale. So that pivot and jewel bearing, that spindle is supported by pivot and jewel bearing. So generally this instrument is put inside a dust proof case. What is the principle of working of the PMC instrument? When current flows through any coil placed inside a magnetic field, so deflecting torque is produced due to Fleming's left hand rule. So this deflecting torque should be opposed by control torque. Generally two phosphor bone springs are there which oppose the deflecting torque. And in PMC instrument, the aluminum coil which prevents the oscillation of the pointer or provide the damping. What is the torque equation here in PMC instrument? See, I the current flowing through the moving coil, F the force acting inside the two coils, mean distance between the wire the R, N the number of turns. So magnetic flux density due to magnet is the B. So what is the force developed that is NBIL Newton. So what is the torque? So it is NBIL multiplied with 2R, that is the Newton meter. So generally number of turns, flux density and all are constant. So deflecting torque proportional to current flowing through this coil. But we know control torque that provided by spring that proportional to theta, the angle of deflection. But pointer comes to steady position where deflecting torque is called the control torque. So theta is directly proportional to I. Here in PMC instrument, the scale of the instrument is linear. What is the advantages of this PMC instrument? In PMC instrument consumes less power, so it has great accuracy. So it has uniform scale. PMC instrument have high torque ratio. It produces no losses due to hysteresis. So and efficient damping is provided due to permanent magnetic field. So this PMC instrument can be modified to ammeter and voltmeter by connecting any suitable resistance either in series or parallel. What is the advantages of the PMC instrument? It can use for DC supply. It is costly. So it is very delicate. So this may show error due to loss of magnetism in permanent magnet. What is the disadvantage of PMC instrument? So it can be used only DC supply only, but it compared to very costly than MI type of instrument. It is very delicate. Thank you.